other VIPs. Right? Thank you for your cooperation, and it's lovely to see everyone here.
Yeah. Jangan cepat dalam.
Yes, tak ambil.
Guys, come in front.
Amma. Oh my. Oh, this. Waka. Remember we used to dance to this song? They had one. They had one song. Oh, they stopped it. They knew they had the judges are dead at the moment. Huh? Aren't the firefighters the judges? Imagine they put APD in your ears to the Come here. I'm still there. Oh, it's one for what is this song? The cat watching
Testing 1, 2. Parents in the back, can you all hear me? Very good. Students in the back, can you all hear me? Very good. Now we'll test the other mic. Parents at the back, can you all hear me? Very good. Students at the back, can you all hear me? So this is the back, not the front. Aye. Alright.
Stop touching the sky.
Calling Mr. Krishnan. Calling for Mr. Krishnan. Mr. Krishnan, please come. Have a seat.
Wondrous good morning to everybody here, to parents sitting around, to our VIPs here, Mr. Dickham Lords and our judge, Ms. Ho Yen Yim, as well as members of the Byline Police, Byline Bomba, Sri Patale, as well as everyone here. Welcome to today's science exhibition. By singing the national anthem. We have a wonderful speech delivered by our principal, Ms. Pranita.
Good morning to all of you.
Good morning.
Every year, I look forward to all the events, and the most important event for nature and all of us is the science exhibition. So it's a great honor and pleasure to have this exhibition going on, not just for the children, but for all. So children, you're doing a wonderful job. A warm welcome to our honorable guests, Mr. Dickham Lutz from the Ministry of Human Affairs. Sorry, Ministry of Human Resources. Thank you, Mr. Welcome to our judges, but we only have one judge right now. Most probably the other judges are coming. We have okay, please come in front. So I will see the judges. The third judge is not here. We have Miss Ho Yen Him from Taylor's University. We have Dr. Molina Darshini from University Malaya. We have Miss Vigneswari Balakrishnan from University Malaya. She's not here yet. She will be coming. So children, you have great judges with you. Alright? And the test is not really in your experiments. The test is also in how you present yourselves. We're going to look at all that. And our great parents, many will come later. Usually when we start, just a few will come, the rest are coming. Most of my students are upstairs. And my wonderful teachers, thank you very much for assisting and putting everything together. Can I have Mr. Rikesh, Miss Hanisha here? Mr. Rikesh here, please. Miss Hanisha. Okay. Yes, these two people are in charge of the science exhibition committee. May we have the committee members? Miss Hanisha and Mr. Rikesh has led the committee, and Mr. Joshua, he's upstairs. And who, you guess, oversees this whole thing? Mr. Prakash, over here please. Good morning, Miss Vigneswari. Thank you. Let's give this team a big hand. Thank you very much. Now, you know, your principal usually doesn't write and speak from the speech paper, right? So I thought I'll try, but no speech paper. I'll just talk with you. I would also like to welcome Dr. Datin Manimala. Thank you very much for joining us. Mr. Krishan from Applied Scholastics. This whole event is a collaboration of many fields. We have Applied Scholastics, we have Genius Asia, we have University Malaya, we have Taylor's University, and of course from the ministry, we have people from Bomba. Thank you very much. So it's a collaboration of so many of them to get this going. It's a wonderful event, and children, very important message. What is the theme of this event? Forces of nature, yeah. But beyond the science and STEM that the whole world is looking at, it's really you, the people of today. How are you going to evolve? Are you going to evolve? Not just the students, including us as well. We evolve every day. Nature calls us into question, and there we go. We can decide to turn into a beautiful being, or we can turn into someone that's otherwise. If you are otherwise, you are of no use to your community, your families, and to the world. But if you turn into a beautiful being, you become so wonderful to all of us. With this, I now say thank you. We have started the Science Exhibition 2024. Thank you.
2025.
Oh, I need to also tell you all, I don't need the mic. This book. 24 character characteristics of a genius. These 24 characters can mold all of us, not just students. And the room on my right-hand side, you will see Mr. Gregory and Mr. Krishnan there, parents, teachers later on, students. You can go into that room and you will be able to understand more about these 24 characteristics. So in Able Learners, we get all of this together, so we give you a proper starting of your journey into life. Again, Science Exhibition 2025. Thank you.
Alright, thank you, Ms. Bonita, for such a wonderful speech, straight from the heart. Now I'd like to invite the VIP, Mr. Dickham, to give his speech as well.
Selamat pagi, selamat sejahtera, selamat Malaysia Madani. Good morning all of you all. Good morning to respected guests, Ms. Principal, teachers and everyone here. My name is Dickham Lutz. I'm from the Ministry of Human Resources. You know what is human resources? Anyone knows student? Never mind, you'll get to nobody. Okay, I'm not really good in speech, so I have to, read my speech here. So please excuse me, alright? So, dear parents, I believe there are some parents here. And so, pegawai daripada Jabatan Bomba, selamat pagi tuan. Okay, good morning to all of you. It is both an honor and joy to be here with you in this very special event, Able Learners' 7th Annual Science Exhibition, and themed so powerfully and appropriately force of nature, right? Okay. So science has always helped us to sense of the world around us. There are natural forces constantly at work, shaping not just the earth, but also our understanding of it. And that's exactly what this exhibition might remind us of the power, the beauty, and the intelligence hidden in the nature. Every idea you explore, every question you dare to ask, every model you build, and every concept you test brings you one step closer to becoming a thoughtful, responsible citizen of the world, and your curiosity is a force. I tell you something, I'm from the Ministry of Human Resources, and we handle humans. Okay? Basically, that's how I have to make you to understand. We handle humans in Malaysia, okay, workers. And also, we are specialists in trainings. What kind of trainings? Tibet trainings, okay? And students, I'm telling you all, of course, most of you all, your ambition is to become a doctor, accountant, what else? Scientists, what else? Engineers, pilot, a lot of big ambitions, correct? But currently, if you're able to understand this, currently, the world is shifting. The world is shifting to Tibet education. And that is the force that's going to drive the world, and it's already changing. And I'm so happy that the school is organizing the science exhibition. And AI and robotic, it is what they call it, game changer, robotic and AI. It's very important. I've been going around with the minister. I went to India, Japan, China. They are very far ahead of us, and awareness should be given to the students from the young, and all the schools, I think they should be continue to give awareness to the students about AI and robotics. And even one day, let's say you want to become a doctor, maybe another 10 or 15 years coming, I think even robots will be doing a doctor's job. That's how fast. And I have seen that in Japan actually. We went to a exhibition with the minister, and there are some operation, doctor will do operation. In Japan, some of the operation is done by the robots. You see? So keep up the good work. I know today there's some competition going on, right? So I'm very bad in following speech actually. I will actually start with it, then I'll feel it. I always feel it is very vague, so I'll just talk whatever in my heart. Okay? So yeah, let me check if I miss out any points here. Yeah, so the Ministry of Human Resources actually we are focusing a lot of high value skilled workforce. And one message to the school: if you need any support from the government, if you need any skill training or guidance or need any specialty, anything, please do come to us. We have a lot of programs, even for the schools. We have Talent Corp, one of the agencies under the Human Resources. They actually give a lot of awareness programs to the school under the Talent Corp. And we welcome the school to approach. And on behalf of the minister, I told to the minister that I'm attending, he's happy and he have extended his wishes to the school. And hopefully we can make it one day, because he goes around a lot of places. My boss is Steven Singh, he's the MP of the Bukit Mutajam, but now currently he's in Johor. So he loves to mingle around with kids, children, because they are our future. And I can see that there's a lot of bright students here. Well done. Really happy to see you. And best wishes to the school, and thank you for inviting me. Thank you everyone.
Thank you, Mr. Dickin, for such a wonderful speech. I can relate with definitely what you say about speeches. Now, let us move on to the giving of the tokens of appreciation to the guests and the VIPs. Yes. Miss Gurita, please come up here.
Yes. The music was too, it's like I think you for meditation. This music is called mood booster. I hope the mood gets boosted. Alright, can we have just this microphone?
Hello, can you hear me? Alright, Mr. Dickin, can you come up for your token of appreciation? Right, Ms. Ho Ling Lim. Dr. Morgana Darshini. Alright, and then we have Ms. Vignaswari.
Thank you. Good round of applause for Bumba. Very important people. Yeah? There's a 6 going rounds. We will call our Bumba president. Right?
Media.
From the media, we have Entamizh Vandangal. Natural voice projection without amplification. Correct? Okay. Yes! So, 10 second science explanation. Basically, I have to use a lot of force to get the voice projected from here, right up, over there, and right up to, who's the last time over there? Okay, one time. Can you hear me? Can you hear me? Okay, very good. So we want to get our MC to project this wonderful voice.
Can everyone hear me?
So I have a theory with everything that happens, it happens for a good reason. Right? So let's make this good, and then I will sort out this table. I have discussion with the table. I'm walking at a particular store, but I can't tell you what store they are going to get. And somehow I am on right. Oh my God. Alright, yes. Please continue.
Okay, photographer.
And this mustache will come out.
Okay, now we have 2 photographers here, Mr. Marvin, who will taking pictures, and Mr. Mahan, our volunteer photographer. You are taking pictures. So how do I get this to you? Yes.
No background music, so we can all clap it, okay? Yes, sir. It's not special because it's also our parent. What? 4 kids are studying here and parents.
Alright, thank you. These are tokens of appreciation for everybody. Now, let us move on to the next part of the ceremony. We would like to invite the teachers here to come up with a very special performance.
Eksperimen dia yang sains
Yes, you guys are doing the science experiment. But perform their own experiments. Okay, so warm welcome for fellow seconds. Okay. Going to do something. Okay, just look like a magic trick, but it's actually pure science. Okay. I want to ask you. Let's say I add stones to this cup, and then I add water to this cup. Okay. What will happen? Okay. What will happen if I turn this cup upside down?
It will fall.
Fall, right? Yes. What will happen to this cup? Water will? Yes. Okay. Why? Due to what?
Gravity.
Very good. Okay. Now, what I'm going to do now? Similar cup. Okay, I'm going to add similar cup. Okay. And then I'm going to add same stones to this. Okay. Yes, sir. Okay. Not magic, pure science. Okay. So, what happens if I swing this cup over my
Stone won't fall.
Raise up your hand. One. Okay, who says it will stay inside?
Oh my god.
Let's see. Okay, so I want you to follow me. Guys, help me count. I need to create momentum. So I want you to count 3 to 1.
3, 2, 1.
Why? It's called centrifugal force. It's a centrifugal force. When it's in circular motion, you can see that the stone actually pushing outwards, and then the tension of the string is actually acting on my head. Okay, so you can see the stone does not
Come on.
Okay, so I can still make this string longer and longer and longer. You can see it stays the same, stays the same. Okay, this is how your planet orbits the
Earth.
planet orbits the sun. Okay, and satellite orbits the Earth.
Earth.
Okay, so this is this.
The Earth orbits around and we will
Okay, so the same setup. I have a wooden plank with spring, and then I'm going to add water. And it's sweet. Okay, I'm going to add water. Yeah. Okay, so now.
Syrup.
Let's go.
We go near VIP, very good.
Okay, you can see that there's no glue to it. There's no glue. Okay, and you can see the water is mixing. Okay, now what will happen? You're going to do the same thing.
What?
But I need your help too. Okay, let's create momentum. Okay, so let's trust physics, sir. Physics teacher. Okay, so what are you going to do? The same thing. Okay, please create momentum with me. 3 to 1. 3, 2, 1. Go. One more. Okay, can you count with me how many turns I can make? Okay. So, okay, momentum. 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Works. Please help Mr. Bani, guys. Science is not about only succeeding, it's also about failing. Okay. This is the last thing. Maybe another. Okay. So I can also do this. Okay. Okay, we continue. All okay? Yes. So now, I want you to come with me like this now. Okay? So, we start. Momentum 3 to 1, please.
3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
There's one thing I like with me. Sometimes we plan and then it doesn't work. But we give up.
No.
We must continue to persist. And we must continue to persist. It is easy to be, problem happen, and you can't do it. But the most important thing is you must continue to persist. Right? So incredible is very possible. This Alisha.
Alright. Apologies, everyone.
Yes, and see that next.
I do. That's what the most important. Anyway, now that we have finished up already, I would like to invite the VIP judges and Miss Punta to inaugurate our science exhibition.
So, led by this
Wouldn't she done that? You're going to take her down. Let's be like this. Let's do life. Movie ends off from the chair.
Bye-bye.
Okay, so we go.
ஆமா அவசரப்பட்டு ரிப்பனை கட்டிட்டாங்களே. What is happening here?
Okay, year 3, group 1, stand up. Year 3, group 1, looking good. Get prepared. Year 3, group 2. Go and get prepared.
No, sir.
I see. Okay.
அப்போ டாக்டர் வந்து அதுக்கு முதல்ல மாதிரி லைட் எடுத்துருக்காங்க லைட் தராங்க விஐபி பார்த்துட்டு போயிட்டாங்களா விஐபி பார்த்துட்டு
ரூமில் வந்து பேசிக்கிட்டு யாரோட என்னோட
இருக்கா போட்டு பாரு ஓடுதானே
நல்லா வளர்த்துருக்கு Oke,
Okay, ready? Guys, all the best. Don't be nervous. Explain. Okay. Waterfall. Thank you. So, listen up. Guys, do your best. No need to be nervous. It's okay to be wrong. Okay, we are learning. Don't be, I must be perfect. No. You do what you know, don't fight each other. Clear? Clear? Don't fight. Don't push. I'm not teacher.
அங்கே மியூட் பண்ணு பிள்ளைங்க பேச ஆரம்பிச்சோன்னா
morning. Okay, we're going to start, alright? When one booth is doing, maybe the other, the volume level. Okay? Ready?
Mute. Not low. Mute.
Okay?
I am Rishi.
Louder. Okay, guys, do whatever you need, okay? 3, 2, 1, go.
I am Rishi. I am Farnika. I am Tatanish. I am Tanu. My name is Namaste. My name is Shailen. My name is Arman.
Okay.
Good morning everyone. We are from year 3 and today we will show you a volcano eruption using safe household materials. Have you wondered how volcanoes explode? Well, let's find out together.
Okay, what is a volcano?
A volcano is an opening in the earth crust and pressure builds up inside the earth. Magma rises and erupts through the surface as lava, ash and gas. The real volcanic eruptions happen because of heat and pressure deep underground. But today we'll recreate a mini version using chemical reaction between baking soda and vinegar, which produces carbon dioxide gas, just like a pressure in real volcano. Here are the materials we use to make our volcano model. Number 1, baking soda. Number 2, red food coloring. Number 3, detergent. Number 4, vinegar. Number 5, plastic cup. Number 6, paint. To make our volcano model. Let's start with
Here, guys. Okay? Okay. Careful, guys. Okay. Do it like this so you can see. Okay. Hold. Tanush, help. You just hold. Okay. Thank you, Namaste. Hold it.
Hold it. Slow. Take out. Now get ready. We're going to pour the vinegar in the bottle. Watch the eruption. It's coming. No disturb. No need for no. It's faster. It's coming up. Come on, just a little bit. No, wait. Enough. Come. It's coming. No, it's popping. Get out. 3, 2, 1. the power of a chemical reaction when waiting for the elements are mixed. They produce gas that bubbles up just like pressure building in a volcano. Here's a fun fact. The largest volcano in our solar system is called Olympus Mons on Mars. And don't worry, our experiment is safe and fun to try at home with adult supervision.
Thank you for watching our volcano eruption. We hope you learned something interesting about science and how volcanoes work. If you have any questions you'd like to ask, please let us know. Because we'd love to answer them. Thank you.
Okay, thank you so much, children.
Thank you.
Thank you for visiting our
Don't take it first. Don't take it first. Right? Leave it first. You're going to receive your cert. And then you pose and then we will clear up. Okay? Listen first. Okay. Listen for your name. Okay. Parmika. Tanush, come here. Ramaswi. Not like that. Hold on. Arman. Caleb. Who give me? Tanish. Rishi. Guys, stand there. You're going to take picture with our judge. Hold your head. Don't step on it, please.
I can help.
Okay, here, group 2.
Okay, ready, please. Ready, shoulder turn. 1, 2, 3. Okay, done. Lower. Lower down. Okay, ready. 1, 2, 3.
Emma, do not cover your face, Emma.
1, 2, 3.
Okay.
Another one, please. Another one. Hello? Lower down, hello.
Okay. Give us the set to Miss Jasmine. Okay, group 2 ready? Okay.
Michael. The button.
Group 2 ready? Okay.
What do you have here? This is a bottle. Grenade and a bottle. What is a tornado? A tornado is a spinning current of air that circulates out and the ground. For moist air, which is called live air, cutting the air to spin because of wind direction and temperature differences. What the experiment shows? We can make real wind, but by swirling water in a bottle. We can create a vortex, which looks like a mini tornado. A spinning motion copies what happens in real life, but safely in a bottle. These are the materials. We use 2 bottles, water, connector, duct tape, food color. This is the experiment. We fill 1 bottle with water. We kept connector and tied with a duct tape.
We will cut you one for you, okay?
So there's also another one.
Okay, done. You can do it.
So next, we added food color. Few
it with duct tape.
Okay.
Next, we spin it in a circle. We spin this in a circular motion. Watch the water spin out like a swirling funnel, just like a tornado. That's beneath because of water. It happened because of a centripetal force or force which pulls objects toward the center when they're spinning. Fun fact, tornadoes can spin at over 300 kilometers per hour and it is measures the feet of curve of F0 to F5. That's how it It's a safe way to see the swim. It's a safe way to see the spinning near how the water behaves like a real tornado. Thank you for watching. Do you have any more questions for us?
Thank you. It learns something.
Yes.
Okay, guys, did you call your name? You go and give yourself some details, okay? Did you call me? And you go and get yourself, okay? Remove yourself. Okay? Hiraji? Aruni? Adi? Ion? Mati? That's the center. Mati, come forward. Come forward. Okay.
Come forward.
Come forward.
Forward. Then compress.
Come here. Come here, guys. Come here. Come here. Mati, come in.
Ready? You ready? Yeah. 1, 2, 3. One more. 1, 2, 3. Okay.
Okay. Okay. What's what you say to the judge? Very good. Okay, third group, get ready. Okay, get ready. Okay.
1 minute, yeah?
Okay, ready? Okay. Group 2, we respect the other group now, okay?
Thank you.
1, 2, 3. One.
Hello everyone, we are from Lava Year 3. Today we are going to show you how to make a lava lamp with no heat at all. It's a simple science experiment and teaches us about density and chemical reactions. What is a lava lamp? A lava lamp is a decorative light that shows blobs of colored liquid and floats up and down in a glass bottle. The blobs move because of heat in a real lava lamp, but will use safe chemical reactions instead. No fan needed or electricity. Materials used. Here's what we need to make our lava lamp. Number 1, jar. Number 2, baking soda. Number 3, cooking oil. Number 4, cup. Number 5, spoon. Number 6, vinegar. Number 7, food coloring. Number 8, LED light. Here are the steps how to make a lava lamp. Step 1. Add 2 spoons of baking soda into the jar. Now fill the rest of the jar with cooking oil. Now take a plastic cup and pour vinegar into the cup. Start food coloring into the vinegar. More, a little bit more. And mix the vinegar and food coloring until the red food coloring is dark. Now add the mixtures into the jar. Because oil and water don't mix. Water is heavier, so it stays at the bottom. As the baking solid dissolves, it produces carbon dioxide gas, which carries the colored water upward into bubbles. As the gas escapes, the blobs sink again, creating a lava lamp effect. Here's how I'm going to explain the fun facts and tips. So here's the fun fact. The original lava lamps were invented in the 1960s and use wax and real heat. But ours is much more safer version. No heat, no electricity, and easy to clean up. Here's the tip. You can restart it by just adding more baking soda. Did you know lava is super hot? It can be 1200 degrees hot. The bubbles move like a real lava in a volcano. There it got its name. That's pretty cool. Thank you.
The closing, okay. Sorry. Okay, once again. Okay, go, do. Yay! Okay. Okay, so teacher. Okay, guys, come inside. Okay, you will receive your cert from the side. Okay, what is your call name? Good name. Come here, guys. Come inside. Okay, once you receive, you will type there. Okay. You good? You can go. Sajid. Stella. Oh. Ritika. Evan. Okay. Now with that, it's over there. Okay, guys. Okay, year 3, can we say thanks to everyone? Thank you. Thank you, everyone. Okay, group photo come. Leave your things, stand in front. Careful. Open your gloves. Okay, go ahead. Be the center, guys. Come forward. Sit.
Down. Okay.
Sit. Everyone come. Sit.
Like that.
Good. Okay.
All teachers go. Okay, ready? One. Let me check. Okay, ready. 1, 2, 3. Okay, freestyle. 1, 2, 3. Okay.
Yay! Say thank you, guys. Thank you, everyone. Very good. Now you can prepare for your demo to your parents, to the audience. Okay, guys? Don't forget your thank you.
Don't forget to share the dance.
Look at the judge and talk. Okay, we will hold the mic. Okay, we can start.
What we will need: two glass jars, 1 can of shaving cream and blue food color to make rain in a jar. Good morning, everybody. Today we are making a rain in a jar. We will see how rain falls from the clouds. Let's follow each step carefully. Let's do an experiment. Put the glasses on the table, fill the glasses with water until they are nearly full. Spray shaving cream on top of the water to make a cloud. Pour some blue food color on top of the shaving cream. What do you see? The blue dots will slowly move through the shaving cream. The blue dots will fall into the water just like rain falls from clouds.
Okay, we can start. Let's start the experiment.
Okay, do the experiment.
First, let's take the shaving cream. Then we put it on top. Next, that's it.
Shake the bottle.
Now.
What's going to happen?
Squeeze, darling, squeeze. Be in the center, squeeze. Literally center.
The cap is on.
Is it? Squeeze tightly, girl.
Like that. It's still, seal is still.
Okay.
It's hard. It's very hard.
Oh, I think.
Okay, how many?
How many drops?
How many drops? Two drops. Is that okay? Is that okay? One more. Okay. Here, how many? No. You cannot. It's very hard. Wait, sorry. I need to. 1, 2. Okay.
Now what's happening? Hey, you want to thank the judge? Thank you. Thank you.
Thank you for watching my experiment.
Okay, good job. Okay. Yes. Okay, guys. Teacher, right? Okay, guys, come here. Teacher will call your name. You go and receive your certificate. Okay? You go. Come this side, guys. Teacher call your name. Then you go to the judges. To the judge. Come here. Adil, Dhanmika, darling, come here. Come this side. Okay. Okay, Adil, go and get your cert. And stand there. Okay, stand there. Okay, Dhanmika. Go to the judge, Mia, darling. Okay, next, Srinika. Stand here. Okay. Okay, Matthew. Okay, stand there. Okay, Mokshi. Okay. Teacher?
Okay, ready. Show your certificate.
Show your certificate. Okay. Lower. Adil, lower, darling. Okay.
Okay, ready? 1, 2, 3. Okay.
Wait, second one, show your face, Matthew, lower. Okay, smile. Okay. Good job. Okay, second group, get ready. Okay, I want to okay, let's start.
Today we're going to see raisin dance. We will use pride to make the raisins move. Let's work together and follow each steps. On 4 packet of raisins, 1 bottle of pride and 1 glass jar. Let's do the experiment. Put the glasses on the table. Open the bottle of pride carefully. Raisins cannot swim, but they can dance. We need glass. We need bottle of Sprite. We need to pour the Sprite into the jar. Then we need raisins. Drop the raisins into the jar. Then the raisin will go up and down. And then our raisins go up and down.
Okay, start. Start, guys. Do your experiment then. Calm down. Now explain what is happening.
Go up and down.
As
The
you can see,
raisins go up and down. See?
what the raisins are doing.
Bubbles going up and down.
They are, what the raisins are doing.
Up, dancing.
Dancing.
Next is another jar. Guys, my reasons. This is my reasons, okay? You put so much, let's put this. These are keep on going up and down.
Now everyone sit. See the dancing raisins. Sit. Everyone sit. See and explain. Explain to teacher.
Now the raisins are going up and down.
What is this up and down called?
Dancing raisins.
Yeah, correct.
Float and sinking.
Yes, floating and sinking. Very good. That's all. Now how you end the experiment? Okay, now face towards here. Yeah. Now you have to. Thank you.
Thank you for watching our experiment. Goodbye.
Okay. Okay, guys, come here. Okay, teacher will call your name. You go and get your slip from the class. Okay, come. Come this side. Come to teacher. Come to Mas Naga. Okay. I call your name. You go there. Judge. Give your certificate. Come here. Okay, Pranav. Okay. Okay. Pranika. Pranav. Show yourself. Okay. Manvi. Pranav. Stand here, please. Okay, Manasvi. Vishwa. Good. Shake hands. Okay, with you, everyone. Turn towards the camera. Turn towards the camera, teacher. No.
Okay, ready. Okay, ready. 1, 2, 3. Okay, freestyle. 1, 2, 3. Okay.
Okay, wait a second.
collect like this.
Miss Busha will collect. Okay? Nice. Give the sun guard. Take it with you, don't worry. Take it with your name. Okay.
Who is that?
Good morning. Good morning. Today we are going to make a couch is powered by wood. So first we need cardboard and bottle caps. Next we need straws. Stitches.
What is the method? How did you make this?
So put the cardboard on the table for the body. Next keep the straws under the cardboard. Inside the straw. And then tie the straw on the cardboard and then tie the balloon onto the straw. Next blow the balloon and then pinch the straw and put it on the floor and then it will move. Thank you for watching our experiment.
And then who beginning? Come this side. Okay. Come this side. Ayan, come this side. Okay. The other one?
One more.
One more. Okay, guys, move. Excuse. Neeraj, can you try? Yeah, baby. Yay! Okay. Okay, say thank you. Say thank you. Say
Thank you. I would like to eat this.
Okay, say thank you.
Thank you. Thank you for listening our experiment and watching.
Okay, now you guys will take search from the judge. Okay, come this side. Come to Miss Lada. Teacher call your name. You go and get your certificate. Okay? Come to Miss Lada. Certificate. Okay, wait. You must go and give it to teacher. What? Okay, wait, darling. Come forward. Okay, Viraj. Okay, Dayan. Okay, Amida. Okay, Bhavya. Okay, come here. Come here. Come here. Let's take photo. Come. With the judge and your teacher. Dayan, you say that again. Okay, teacher. That's your book. That's your book.
Ready, you are.
That's your book.
You are.
Okay. This one, last close. Now. You are ready? You guys ready? Okay, quiet down. Let's be here. Watch.
Today we're going to make a volcano. We will see how it looks. Let's go each step together carefully. First, we will need a plastic bottle and a cardboard box. Second, we will need clay, baking soda, and vinegar. It's food coloring. Let's make it. First, we take the cardboard box and cut it like this. Second, we take the plastic bottle and put it in the middle. Put the clay around the bottle. Third, add baking soda into the bottle. Now slowly pour vinegar into the volcano. Add food coloring inside the bottle. After all the things react, the volcano will erupt. Thank you for watching our experiment. Thank you for listening to our experiment.
You want waterfall? Here to waterfall. Waterfall. Respect the other room. Give space. Thank you. Give space. Okay, that's easy. Okay, wait. Please move aside. Just come aside. It's okay. It's okay. No problem. Don't tell me come aside. Okay, sit for the Okay, relax. Come aside. Oh, no problem. No problem. Okay. So what is happening now?
It's erupting!
What is happening that is coming out of the volcano?
Lava!
What is lava?
Lava is a melted rock that comes out of a volcano.
Yes. And why it happened?
Because when the earth has so much pressure, then the volcano will erupt.
Yes. Correct. Very good. Very good. Okay. Okay, guys. Let's get your shirt from inside. Come to this Lala. Look to come to this Lala. Come here. Okay. Tissue paper and me. Okay? Okay. Say honey. Ayah. Breathe it in. Okay, come center. Sit beside your friend. Okay. Arthur. Okay. Breathe. Okay. Lucky. Stand there. Show yourself. Okay. Lucky, stand there. Okay. Teacher. Please. Guys, I'm going here. Guys, you I see. Be here. You are.
Okay, now group, all student, accident.
Group photo. I'm Sansha. Come 1, 2. Come let's take picture. Come 1, 2.
Face side. Okay. Okay, now, all those monkeys.
Just one more.
Okay. Oh, just be careful. Okay, ready. Okay.
From this side.
Teachers behind. Okay, ready, yeah? 1, 2. Look at it. 1, 2, 3. Okay, which side? 1, 2, 3. Okay, thank you.
Okay. Guys, please don't go here yet. Please go to your booth, the other side. Please, students.
Okay, 1, 2, 3.
Good morning, everyone. Good morning. How's that?
Good morning,
Good morning. So, booth 8 will present first.
Hello everyone. Our project is called the parachute drop. My name is Rishnita.
My name is Amma.
My name is Aditri.
My name is Aida.
My name is Anika.
My name is Nandan.
How does a parachute slow down the fall of an object?
We thought that if we attached a parachute to a small object, then air resistance would slow it down compared to dropping it without a parachute. How does it work? In our experiment, we made a parachute from a plastic bag and string. We attached it to a small toy and dropped it from a height.
Also not the same toy. Without a parachute, you see the difference. Scientific concept. This project shows gravity pulling on the toy and air resistance pushing against the parachute. The parachute makes surface area and creates drag which slows down the fall. Expected outcome and conclusion. As expected, the toy with the parachute fell down slowly and landed softly, while the toy without the parachute landed much faster. This shows how air resistance works. Materials. Plastic bag, small and big. Physics, small toys. Scissors.
Blue.
Tape. Objectives.
The purpose of doing this project is to see air resistance.
How does a parachute slow down the fall of an object?
A parachute slows down the fall of an object because the parachute's hull is large and more air will go inside the parachute. So the parachute will land softly. Experiment steps. Step 1. Cut a square from a plastic bag or a tissue paper about 20 cm by 20 cm. Step 2. Tape one string each corner of the parachute. Tie all the string ends up to the small object. Step 4. Drop the small object without the parachute from a certain height. Step 5. Observe how fast it falls. Step 6. Now drop the small object with the parachute from the same height. Step 7. Observe and compare the parachutes. Excuse us to stand on it. Excuse us, we have to stand on it. Of course. Oh. Okay. 1, 2, 3, drop. It's okay. As expected, the smaller parachute fell down a bit more faster than the larger parachute. This shows air resistance, and the toy without the parachute fell much faster. This shows how air resistance works. Good. Fun facts. NASA uses parachutes for spacecraft landings. Parachutes are used to slow down spacecraft on returning to the Earth or landing on other planets like the Mars rovers.
Even food has been parachuted. In 2015, someone in Canada dropped a Big Mac from a drone with a parachute attached to it, and the experiment landed safely.
The bigger the parachute, the slower the fall. Larger parachutes usually fall more slowly. Why? Because they use air increasing drag. You can test it by different sizes to explore this. Parachutes were inspired by Leonardo da Vinci. The idea of the parachute dates back to Leonardo da Vinci in the 15th century. He sketched a design for a pyramid-shaped parachute centuries before the first successful jump. Thank you for listening to our presentation on the parachute drop. 1, 2, 3 parachute.
Okay, thank you so much. Okay, okay, guys. Students, come follow teacher Radha here. Come this side. Teacher, call your name. Go collect your certificate and then tell me. What must you say? Okay. Rushmita. Okay. Aman, Abid. Come here, Lalit. Aditri. Ira. Randan. Anika. Don't, Anika, don't go behind the wall. Teacher, go.
Ready? 1, 2, 3. One more. 1, 2, 3. Please start. 1, 2, 3. Okay, thank you.
Okay, group 2, ready? Yes. Okay, ignore information. Okay? Look at picture only, okay? I want the best, huh? Okay. Here we go. 3, 2, 1.
Hello everyone. My name is Anya. My name is Arif. My name is Hasni. My name is Debbie. My name is Joel. And my name is Nitya. Our project is called the Screaming Balloons. Our question was, What happens when we keep a coin inside the inflated balloon? Which object makes a louder screaming sound in a balloon? A coin or a hex nut? We thought if we put a coin inside the balloon and spin it, the coin inside the balloon would spin fast and make a hissing sound. For our project, we put a coin inside a balloon, blew it up and tied. Then we held the balloon by a knot and spin it in a circular motion. Then the coin spins fastly inside the balloon. These projects show centrifugal force which keep the coin pressed against the balloon's wall. The friction between the spinning coin and the balloon makes the hissing sound. Materials. Number 1, 2 balloons. Number 2, 1 hex nut, small. Number 3, 1 coin pencil. Number 4, hands to spin the balloon. Now experiments. Number 1, put a hex nut into a balloon. Number 2, put the coin into another balloon. Number 3, blow both balloons in center. Number 4, hold and spin the balloons. Number 5, now spin the balloon with the coin. Listen again. Number 6, compare the two sounds. See the results. Now we're going to have our conclusion. The hex nut makes a loud screaming sound because it has edges that cause more vibration. The coin is used to round and smooth so it doesn't make much sound. Fun facts. The hex nut acts like a tiny musical instrument like inside the balloon. Its shape makes it sing. Thank you for listening to our explanation about the screaming balloons.
Tanya, you didn't show, you wanted to show, right? The demo? Putting the balloon, the hat in the balloon. Show. Show to the judge. Repeat the steps. Okay, Nitya, move with the link. Show your steps. Very good.
It won't spin properly because the base of the coin is not thick enough. Now it's the hex nut. So we're going to put the hex nut inside the balloon. Now spin. It makes a real hissing sound because the hex nut is hitting the balloon's wall. It's also called the centrifugal force. Thank you for listening to our presentation about the screaming balloons.
Okay, group 2, come this way. Clap, nice clap. Okay. Come to Miss Naga. You have received cert from Jaja. Come here. Okay, come here. Come back here. Okay, Nitya. Danya. Hasni. Chandri. Judith. Arish. Don't repeat yourself. Don't cover your face, You guys wait, we don't repeat.
Ready,
Don't cover your face,
1, 2, 3. 1, 2, 3. Okay, please start. 1, 2, 3. Wait. Don't move.
Okay, now come group.
Go. Okay, go. Okay, all teachers. Okay, ready. 1, 2, 3. One more. 1, 2, 3. Okay.
Not that. The first one.
Matthew, what's the just dali?
Walking water is here.
Welcome to Watch Walking Water. Welcome to Watch Walking Water. Discover the cutest signs on our route. Let us watch water dance and colors bloom, revealing the magic of science.
Hi everyone, my name is Vasavi.
Hi everyone, my name is Kavinaya.
Hello everyone, my name is Purity.
And my name is Sahana.
We are the
H2O girls.
Hi everyone, today we'll be sharing our project called Walking Water.
I have a question.
Me too.
Does water actually walk?
That's a good question. Water doesn't walk, it travels.
Our question was, how can water move into another cup without being poured? Impossible, right?
Yeah, but I am here to talk to you about this. We thought that if we use paper towels in between cups, then the water would move along the cups. But first, let me let you know about the materials. First, we need a paper towel roll. Second, we need a hair dryer. Most importantly, food coloring, cups, and water.
Now let my teammate tell the steps.
The first step is, we're going to place cups in one row. 5 cups in one row. And 3 of the cups are filled with colored water. And 2 of the empty cups are empty. Next, we're going to roll up tissue paper and put them in between each cups. And after an hour, you'll see the empty cups filled with a new colored water. Like how the results show here. This is our results because we keep these 2 cups empty. And these 3 cups are filled with colored water. So the different colors mix together and make a new color.
After that, take out the tissue paper gently so it doesn't tear and dry it for a few minutes. After that, you'll see a beautiful scenery in the paper towels. Example like this. Now let's show the demo.
Let us show you a demonstration this way. First, we will pour water into the cups and leave each one in between empty.
We always need to keep them at the same length so that it won't overflow and the colors won't be too less or too much. And in the end, you will see all the cups have the same amount of water. Now it's time for the food coloring.
First, we'll put green, then we'll put yellow, and then we'll put red.
Yellow. And lastly, red.
Then we'll put these folded pieces of tissue paper into the cup.
You can see the color already. That is called capillary action. If you see over here, the water actually walks.
Like she said, it is capillary action. But some of you might be wondering, what is capillary action?
And our teammate is here to say it. Capillary action is when the colored water goes through the tissue with small gap, which is called fibers. If you see over here, capillary action does not retain gravity or oxygen. This is an example. If you put water to the stem, you will grab the roots and give to the stem, which makes the leaves white, like the water have the same measurement. Another example is when blood goes through the tube of your arm. Now we'll try aluminium foil. What is the aluminium foil not absorbing water?
As you can see, the aluminum foil is not absorbing water, but the tissue paper is absorbing water. And we have a teammate to explain why is that.
It's because the aluminium is non-absorbent. It doesn't absorb the water as the paper towels and fabric. And it is non-porable. That is called capillary action.
And aluminium foil does not give gap for the water to travel.
There's no room for the water to travel through aluminium foil. Unlike a tissue paper, there is room for the water to absorb through and create a beautiful scenery. Right now, we don't have the scenery to show you, but you can also see this demo that we have done some days ago.
It will take 1 hour or more than 1 hour to become like this. Thank you for listening.
Thank you for showing. Pretty actually.
Would you like the chocolate?
Oh, definitely. Thank you. Who came up with this idea?
We all made the idea.
What? I have no idea. Good job. Thank you so much.
So much.
Okay. Certificate. Teacher, you stand there. Okay, guys. The year 4 come inside. Some of you are guys. Oh, year 4. Sorry, I think year 4. Sorry. Okay, I'll call your name. Go and see your certificate. Okay, and then read that photo. Okay.
Then after you get the certificate, you go.
So you go inside. I want to get color. Come this way. Okay, see that. Okay, Davina. This way. Okay, Purity. Sahana.
Okay, ready, yeah? 1, 2, 3. Teacher, come forward, teacher. And then go. Okay, then. Thank you. Okay, ready, 1, 2, 3. Okay, which side? 1, 2, 3. Okay, thank you.
Thank you. Good job. Okay. I love you.
My name is Danica. Our project name is the Mini. What's the wheel?
And our team name is the Aurora Science Legends. Problem statement. Our question was, can flowing water be used to turn a wheel and show how water's energy can be converted into motion?
Problem statement. This project shows energy transfer where the kinetic energy of moving water spins the wheel. Water wheels are an example of renewable energy.
Setup. How it works. We built our water wheel we used straw, plastic bottle, a cap, a stick, and a tube.
As expected, water force turned the wheel. This shows how people use waterway for centuries, grind, grain, or generate power.
Now we are going to show you a small demonstration of mini water wheel. As you could see, the water force turned the wheel. So, when water was going on the box, the water was stored in this. Fun fact: today, waterways are being reconsidered into small-scale electric generation, natural electricity. Thank you for listening to our project, the Mini Water Wheel.
Very good. Okay, guys, come this way. You want to see your sir? Okay, I will come this side. You take your sir. You take your sir. Come, teacher call you. When teacher call you, you take your sir. Come back there, okay? Go to your place, okay? Okay. Yanika. Yeah, from the judge. No, look there. Look there. Yeah. Daddy, you remember? Okay, Dharmika. Don't show your back okay. Okay, Roshni. Okay, Tashvi.
Oh, like that.
Okay, stand there. Teacher. Come up with
Come up with because it's covered.
Don't go behind the box.
Okay, teacher. Teacher.
Yes, teacher. Oh, teacher. Keep the body sideways. Here, Danica. In. Yes. Sideways. Okay.
Then teacher come.
Put it down. You're blocking your face.
Okay, ready. 1, 2, 3. One more. 1, 2, 3. Wait, let me double check. Okay, thank you.
Welcome.
Come, can I get it? My name is Sahasra. Today we will look at the egg drop protection project. The egg dropper trio. The problem we wanted to solve was how can a falling egg be protected and drop from a specific height? The scientific concepts are used in this experiment are gravity, impact force, and energy absorption. This shows how different materials like cotton, tissue paper, and bubble wrap can absorb shock and protect an egg. Setup and how it works. We designed a protective layer like this using stuff like tape, tissue, cotton, bubble wrap, and scissors to cut them. We designed something like this. The goal was to protect the egg from cracking.
Expectation and conclusion. We expected the materials to absorb the impact. When the egg, we dropped two types of egg. One egg with less protection with only one layer of bubble wrap and one with more protection like this. So when we dropped the egg with less protection, it cracked, which means the design it didn't work, which means we must improve. So we improved to the egg which has more protection compared to this. So when it was dropped, the egg was unbroken, which means our design worked. Now Zan will tell about energy absorption.
The main scientific concept that was used in the experiment was energy absorption. Energy absorption is a process where different materials like cotton absorb a type of energy and convert it into a different type of energy. For example, when the egg touches the cotton will absorb the energy and it will convert it to a different type.
You might be thinking, what are practical applications? Practical applications can be car crashes, such as when a car collides to a truck, before the driver hits the steering wheel, the airbag deploys, which protects the human's body parts. This is the same thing for the other passengers who are sitting in the car. And one more, protective gear. It can be helmets, these elbow pads, or this knee pads. Now, I'm going to show you a demo. Sorry, please hold this for me. So we are gonna drop it at this height. So, do you think the egg will survive or not?
Is this with less protection or more? Of course, I think it will be protected.
As you can see, the egg remains tight. Yeah, and it cracked a little. Yeah. So that means that the cotton absorbed it. Because it was loose, the egg got a little bit broken. So we are now gonna change it. Thank you.
Thank you.
Okay, thank you. You will call your name, you receive the certificate, and you go back and stand again. Alright? Moving, so you take a sip, you say, okay? Moving. Sahasra. And Zaru.
Teacher? No.
Hold on. Don't block yourself.
Okay, ready? Okay, ready? 1, 2, 3. One more. 1, 2, 3. Okay, freestyle. 1, 2, 3. Okay, thank you.
Okay, year 5. Can we have a group photo?
Group photo. Here. Group photo here.
Okay, can I have the cotton wasn't placed properly. Guys, good.
Listen up.
Come, moving. Sastra. Dharmika. Kneel down. Okay, the rest of you should kneel down. Come, go. Just give some space for me to walk. One line here. Come here. Last one. Okay. Can you kneel down?
Okay, kneel down, kids.
Kneel down.
Okay, you compress. No, compress.
Beauty, come beside.
Okay, ready, yeah?
Beauty, come beside. Beauty, can you kneel down?
Okay, ready? 1, 2, 3. One more. 1, 2, 3. Okay, thank you.
Thank you.
Just think of it.
We're gonna throw it in that dustbin. Calm down. Relax. Calm down.
Thank you.
Okay, get ready.
Hello there, and welcome to our group for Hello there, and welcome to our group Tornado Stories. Today we'll be presenting about the tornado in a jar. But before we begin with the actual presentation, let's go through our group members first.
My name is David Thomas. My name is Asta. My name is Harshini.
My name is Kabisha.
And my name is Ashuboda. Let's begin.
Natural disasters rarely occur, but we still have to keep a good attention on them because of what they can do to us and our surroundings with the likes of tornadoes, volcanoes, earthquakes, and hurricanes. But we will be focusing on tornadoes, specifically tornado in a jar. Tornadoes use centripetal force. Now your question may be, what is centripetal force?
Centripetal force is when an object is put to the center to another object. That is called centripetal force.
Examples of centripetal force. When you stir a cup of tea and the leaves gather in the middle. The second example would be a roller coaster loop. The track pushes the coaster inward so it doesn't fly off the top.
You guys may think, will the tornado size change in each jar? Yes, it will. When the jar is wide and big, the tornado will be wide and will need more force. When the jar is small, the tornado will be small and will need less force. The question we wanted to answer is, how can the motion of the water be used to create a vortex like a tornado?
The hypothesis, we think that if you take a clear jar and added some water and spin it in a circular motion, the vortex in the jar will look like a tornado.
Now you may ask, how is a tornado in a jar? As I explain step by step, kindly pick your jar as we will conduct our experiment. Firstly, add 3/4 of water or near to the top. Secondly, pour a bit of dish soap or you can add a few drops. Kindly pick out of red, green and yellow. Red. After that, add a bit of dish soap. After that has been completed, add some food coloring. Kindly pick your beads.
Maybe you don't know, you should know.
You should know.
Okay, then you go with yours.
After that, seal the lid tightly so nothing flies around. After that, shake it to mix everything up. Turn on your light and watch your tornado spin. Asta, I have a question. Why should we add this soap? We should add this soap so that it is possible to see the tornado. We can also add food coloring so we can see how big or small the tornado is.
Scientific concept. Our project shows how a vortex forms in water using centripetal force, which we explained beforehand. This is similar to how tornadoes form in real life.
As we expected, when we spun the jar, a spiral vortex formed, looking just like a small tornado. This is how the spinning force and motion can make a visible vortex. Now the best part, fun facts. Firstly, tornado winds are one of or the fastest winds on earth. Tornadoes don't hit big cities.
Tornadoes can't cross lakes and rivers.
Tornadoes produce winds exceeding 250 meters per hour.
And lastly, tornadoes can get as large up to 1 mile long, or they can last up to 50 miles in length on ground.
Thank you.
Thank you.
Cool, guys. You're going to receive your certs from the judge. Okay, come here. Okay, come. Okay. So you receive, you go and wait. Okay. First name Harshini. Ashuboda. Thomas. Kabisha. Asta.
Okay, ready. Don't cover your face. Okay, ready. One, two, three. One, two, three. Come on. One, two, three. Okay, freestyle. One, two, three. Okay, thank you.
Next, yeah, okay.
We can do that. Thank you. Good job.
Good morning, everyone. My name is Jay, and our group name is called the Airbenders. Our project is called the CD hovercraft. So, what is a hovercraft? A hovercraft is a vehicle that can float on land, water, and even ice. What materials we use for this experiment? We used a bottle cap, a CD, a balloon, and a hot glue gun. We started by gluing the bottle cap to the CD. Then we inflated a balloon and sealed it over the bottle cap. The question we want to find out is, can air pressure be used to lift and reduce the friction between the surface and the object?
Hi everyone, my name is Ahra. The CD hovercraft demonstrates the principle of air pressure and friction reduction. It uses pop-up bottle cap and a CD and a balloon. So the CD used as the hovercraft base and the bottle cap glued at the CD's hole and act as the air valve. And then the balloon inflated and stretched over the cap, and then the air released through the cap when we pull up. For example, like this, the hole. And then air forms a cushion between the surface and the CD. Our project uses Newton's third law of motion, action, reaction, air pressure. And since it's using air friction reduction, it forms an air cushion between the surface and the CD. So, when the eliminating friction. Friction happens when two things rub together. You may ask, what is friction? Friction is two things when rubbed together. So, if there is no friction, the CD will glide smoothly. If there's more friction, it won't glide smoothly. Thank you.
My name is Vaiga and I'll be explaining the experiment. So first we start by inflating the balloon. We will be using an electric pump for this. Then, would you like to choose a CD? Like this. Okay. Then we seal the balloon over the bottle cap. After that, the air is under pressure. When we open the bottle cap, the air escapes out through the hole of the CD and forms an air cushion between the surface and the object. The reason why it makes loud sounds is because of these materials. It makes the CD heavy and this type of balloon also.
Now I'm going to conclude this experiment. As expected, the air between the surface and the object was reduced, allowing the object to glide smoothly across the table or the surface. This demonstrates how real hovercrafts can float on land, water or ice. Fun facts. Did you know the first working hovercraft was created in 1959 by Christopher Crokeller?
Benefits of using a hovercraft in real life is military and rescue teams use it because it's faster than boats or any other water vehicles.
For example, military may go and help the other countries, then the other countries have the weather, winter. For an example, ice. So the military use CD hovercraft because it can glide in ice, land and water. You may see this can float on water. Wait, let me show you. These are the pieces, and then slowly and it will make bubbles because it will go faster. Because air is the water, right? So it makes bubbles. This is how it works. So thank you for listening. Do you have any question you may ask?
What is the principle you mentioned just now about the Newton's third law?
Yeah.
Can you repeat that?
So Newton's law uses action, reaction, air pressure because Newton's law is also gliding smoothly in the surface. So that's the third law of motion. That's why we are using Newton's third law. If we don't use, it won't glide smoothly or make friction. Because Newton's third law have friction and gliding smoothly on. So that's why. So on. They have except at ETC more and more in friction. And because of friction, it will glide smoothly. When the friction reduces, it glides smoothly. Like if we don't have friction, it will glide smoothly. But we need friction sometimes.
Alright, why do you think so?
Because friction, if we don't friction, we will go around everywhere. We can't stop. So if we have friction only, we can stand around. That's why.
Got it? Okay, cool.
We can also hold things like to hold this mic, for example, we need friction.
Yes.
Without friction, it will be like sliding.
Yeah, I know, and I think that's the reason why we have your shoes.
Yeah.
Because of that, you can't just like slip away, right? Good.
Thank you.
Thank you.
Thank you.
Okay, guys. You should only give yourself one right extender. Okay. Awan. Okay, go back to your book, right? Okay.
Okay, ready? Yeah, 1, 2, 3. One more. 1, 2, 3. Okay.
Okay, are you ready?
Good afternoon, everyone. So today we're going to present our project on electromagnetic lifter. My name is Niranjana. My name is Varshini.
My name is Sheshadri.
My name is Arvind. The problem we wanted to solve was, can electricity be used to create a magnetic field strong enough to lift small metal objects? The hypothesis. More coils wrapped around an iron nail makes the magnetic field stronger, which allows it to lift small metal objects. This project demonstrates how electric current can create a magnetic field. This is called electromagnet, which is used in real life in things such as screens, electric bells, tingling, and motors.
For this experiment, an iron nail was tightly wrapped with insulated copper wire. The end of the wires were connected to a battery. When the circuit was complete, it could lift small metal objects like staples, coins, or paper clips.
As expected, when the battery was connected, the nail lifted up the paper clips. Showing the electricity can create a temporary magnet. When the battery was disconnected, the magnetism stopped. This proves that the magnetic field was caused by the electric current. The more copper wires wrapped around the nail makes the electromagnetic strong. The less copper wires makes it weak. Here's an example. There's a magnet connected with two different poles facing each other, and that creates a small a magnetic field. like the example we showed over here. Thank you for listening to our presentation on electromagnetic lifter. Would you like to try?
Do you think you could lift the coin up?
Yeah, let's do it. Yeah.
Thank you. So you're saying that if you're gonna like increase that power or the current, you've got to like add up more coils, right?
Yeah. Or you could add a stronger battery.
Got it. So you have more current, right?
Yes.
Do you have any other factors that could increase the magnetic force? Okay. So if you have a metal or a solenoid, you call that. If you have a metal very near to this particular system, it would also enhance the electromagnetism as well. Like for example, this is a metal. If I just put near this, it enhance the conductivity. So you have more factors, and you'll learn that soon, I guess. Okay, good job.
Thank you. Thank you, ma'am.
Vashini, Shadri, Deshadri, Niranjan.
Okay, now. Okay, ready? 1, 2, 3. 1, 2, 3. Okay, freestyle. 1, 2, 3. Now kids. Come outside. Outside. Group photo.
Come, year 6. Can you all bring down there? Some of you kneel down. Okay, thank you. Niranjana, Shadri, come. The last group, kneel down. Okay, the rest of you come. Closer.
No more space.
Okay, ready? This side. Okay, closer. Okay, ready? 1. Okay, ready? 1, 2, 3. 1, 2, 3. Okay, freestyle. 1, 2, 3.
Here, so
Okay, thank you.
bye bye here.
Thank you, Yasik. Thank you. Yes, sir. Yeah, yes,
Hydraulic is the science of using liquids to create force and Hydraulic is the science of using liquid to create force and pressure. Now we wanted to test out How does water pressure allow a simple mechanical arm to lift objects just like a human arm? And we hypothesize that water is used to imitate the contraction and relaxation of the arm to lift up objects more easily. Now, you can see the concept of hydraulics in everywhere now because globalization and industrialization, right? Now, the most prominent concept of hydraulics in Malaysia itself is your Kuala Terengganu drawbridge. Now, what the bridge does is it has two movable leaf stems. Okay, so once it opens up, it allows for cargo ships for imports and exports to go through. Because if the bridge were to close, the ships can't go through because they're too large in size. And another one famous example we have is the excavator arm. Come on now, we see excavators and cranes almost everywhere in Malaysia now. Okay, now an excavator arm is also a really popular example of hydraulic, and it's used for digging, lifting, and even demolishing. Now I'll be passing it on to my good friend Gashigan to explain the science behind hydraulics.
Now I'll be explaining about Pascal's law and how the hydraulic arm works. So when I push down on this syringe, the water flows through the delivery tube to the other syringe and it goes up. This is due to Pascal's law, which states that when water is applied to a liquid in a sealed container, pressure is distributed evenly throughout the liquid and the container. Now how this hydraulic arm works is, when I press down on this syringe, it rotates the base of this hydraulic arm, and when I pull it back, it goes back to its original form. And the second syringe controls whether the arm moves up or down. And the third syringe controls where the claw is placed. It can go down and up. And the final syringe opens and closes the claw. And the materials used to build this hydraulic arm is the battery, the popsicle stick, cardboard, syringe, skewer, delivery tube, and cable ties. So now I'll be passing it on to Advika to explain about the hydraulic bridge and how it works.
Thank you, Kashian, for passing it on to me. So, judges, take a look at this. This is a hydraulic bridge. So, what is this actually made of? This is made of sticks, wooden skewers, tubings, and cable ties with syringes. So, you might think that actually the sticks are the most important because, of course, the base is made with this. But actually, the syringes, the cable ties, and the tubing is the most important part. Because if you don't attach these, the movement of the water won't be allowed. So now I'll be demonstrating how this actually works. Okay, so when I push this syringe, this bridge is going to move up. So what this is actually doing, I'm exerting pressure and the water movement is allowed through the tubing. When I pull this back, it's going to go back to its original shape. Yes. Would you like to try?
Yeah. Do you guys want to try? You also want to try? We have to check. Wow. You want to try? Yeah, just push.
Yeah, pull it back. You can put it back. Thank you so much. I'll be passing it on to my good friend Oswin.
So thank you, Advika, for the beautiful explanation on the hydraulic bridge. So I would like to start by asking you a question. Do you know that there are two types of hydraulics? Let me enlighten you. There are two types of hydraulics: hydrodynamic and hydrostatic. First, I'm going to be starting with hydrostatic hydraulic. Hydrostatic is basically the study of fluid pressure. Kashigan and Advika explained about the hydraulic arm and the hydraulic bridge. It uses fluid pressure, which is hydrostatic. Hydrostatic also studies the weight and depth of fluid, which gives the fluid pressure to it. Examples are excavators, hydraulic bridge, and hydraulic arm. Next, I'm going to be talking about hydrodynamic hydraulics. Hydrodynamics is not very common and many people don't know about it. Hydrodynamics is the study of fluid movement. It does not emphasize on the fluid pressure, but on the movement itself. And also, it examines the force that makes the fluid flow. Many people won't know that hydraulics was used even in 6000 BC by the Egyptian civilization. They used it to irrigate plants, and also the Mesopotamian Empire also used it. An example in real life is water flowing through pipes. Now I'm going to be explaining about the advantages of hydraulics. There are many advantages of hydraulics. First, it provides a greater force with just little force applied over a large distance. Example, this syringe. This is a smaller one and this is a larger one. When I apply force here, the other syringe also moves, which is in larger distance. This shows force multiplication. Secondly, it allows a smooth and precise movement, which allows for better control. Lastly, and the most important thing is, it is very compact. As you can see, it's very compact, which allows it to be used in car braking system, in airplanes, and you can see here some examples in dentist care, hydraulic lifts, and hydraulic brakes. And now I'm going to be passing on to Chan.
Thank you for my teammates' lovely explanation. But the important question is, can you improve our future? Well, of course you can. Because hydraulics are already being used for smart construction and farming machines. For example, construction or excavators are using hydraulics to automatically adjust the power to save more fuel and reduce pollution. And also, modern hydraulic systems can be eco-friendly and energy efficient. For example, solar panel tracking systems and hydraulic wind turbine brakes can make renewable energy much more reliable. Thank you for listening to me. I'll be passing it back to Abika to conclude.
So, thank you, Chan, for talking about our future. So, as you can see, hydraulics are being used everywhere in the world. And like Chan said, it's going to improve the future. So, we made these two models just to give you a little idea of hydraulics. Now, thank you so much. This is all from my architects. Thank you so much for listening to
Congratulations, well done. Congratulations, well done. Congrats.
Thank you.
Congratulations.
Thank you. Compress here. Okay, compress.
You want me? I can go down.
Okay, go down. Better. Kneel down. So that the teacher can. Okay, perfect. Now ready? 1, 2, 3. More. Okay, freestyle. 1, 2, 3. Okay, now push up. All of you. Okay. So there, all of you. Ladies and judges.
Thank you so much for listening.
No questions.
Any more questions? Please ask me. Go ahead.
The space behind so that the picture and the history. Everybody will know. So judge and on your knees. Okay, judge behind, teacher behind. Close. You go there. Okay, you just stand there. You stand. One. Okay, ready, yeah? Okay, ready. 1, 2, 3. See this first. 1, 2, 3. Wait, let me double check. Okay, now freestyle. 1, 2, 3. One more. 1, 2, 3. Okay, thank you.
Thank you.
That was fun.
Yes.
What you transfer it is that.
Oh, okay, so you got the wire.
Yeah, the wire should be. So I put it right here.
So it's pinching, push it out.
Yeah.
These are all made with so all of them are like cardboard. All of this is nothing that counts. Yeah. Like my name.
We love
Love all every love.
Yeah.
Yes. Thank you. Any more questions? Any more questions?
Thank you.
Can you explain what your project?
Yeah, what do you need for the
I'll be explaining about the hydraulic valve and the mechanical theory behind it. So my friend pushes down on the swing, the water comes through the generator, and then the other friend pushes the hydraulic valve. So this is called Pascal's law. Pascal's law states that when pressure is applied to a liquid in a confined state, pressure is distributed equally through the
Hi, my name is Veda and this is Team Freefall Formula. This is Atir, Emmanuel, Bavinia and Aaron, and today we'll be talking about parachute time trials. Now before we go towards the experiment, I'll be starting with the scientific laws and principles. To begin with, I'll be talking about the Newton's 3 laws of motion. First law being inertia, second law being the important formula in physics, force is equal to mass times acceleration, and the third law, action reaction. Now I'll be also talking about the Bernoulli's principle, which basically talks about how pressure difference affects the descent of the parachute, and this is aerodynamics, which is basically the study of how objects move through air.
So different parachute has different sizes, different shapes. Now they will try the parachute with the cap drop height, with weight and string length constant.
This is of different surface area. We made it of plastic garbage bag, 300 centimeters square, 600 centimeters square, 900 centimeters square. Drop height constant, weight constant, string length constant. 1, 2, 3.
From this experiment, you can see that the largest parachute took the longest time to fall. This is because with a larger surface area, it can trap more air underneath it, which increases its air resistance. The air resistance works in the opposite reaction of gravity. When these two forces react against each other, the descent time of the parachute will slow down.
Now this is of different shapes. We have triangle, circle and square. The drop height constant, weight constant and string length constant. 1, 3. Yeah.
Now, in this experiment, you can see that the circular parachute took the longest time to fall and was the most stable. This is why most parachutes you see are circular in shape instead of triangular or square.
Now, the next one is of different materials. The surface area is 600 centimeters square. We have paper, plastic, and nylon cloth. Top height constant, weight constant, and string length constant. 1, 2, 3.
Now, in our final experiment, although the paper parachute did take the longest time to fall, and people may think that it's a reliable material to make parachutes out of, it's actually not. Paper parachutes are heavy, they're rigid, and not flexible, so they can't trap air well. Nylon parachutes are flexible, but they have tiny, minuscule holes in them if you look closely, so the air will pass right through it. With plastic parachutes, you don't get either of those problems. They have no holes in them, they're very flexible, and they're lightweight, which make them the most reliable material to make parachutes out of.
Overall, our experiment shows that simple changes by changing the size, the shape, and the material used can greatly impact the quality and the effectiveness of the parachute. Simply by changing the material from paper to plastic, changing the size from square to circle, and changing the size from a smaller parachute to a larger one, it can really impact how useful and how well it performs. This plastic parachute is actually used as a baseline for many models of parachutes that are used in your day-to-day life by many other people. So it's actually used during emergency rescue operations, skydiving, military use, and even space missions. Thank you. This is our experiment on parachute time trial.
So, good day, judges. So, my name is Avi. I'm from year 10, and these are my teammates Adavan, Hilary, and Harika. And we are Inferno. And the experiment that we have conducted is fire snake. So, Hilary, do you mind explaining what is fire snake?
It is the burning of sugar to form a snake-like structure, like this one right here.
Okay, so the material that is used to conduct this experiment is non-flammable clay. So, Harika, why do we use non-flammable clay?
So things don't catch on fire and it won't be a fire hazard.
Second is sand.
Sand helps to insulate the experiment, so we're keeping it warm as the fire will do.
Third is sugar, which is one of the vital elements for this. And basically, all of this is sugar, so it's one of the vital elements for this experiment. Fourth, baking soda.
Baking soda is burnt to produce carbon dioxide that will help push the snake out.
Fifth, ethanol is another vital element for this experiment, has helps to conduct the fire. And my friend here will be explaining about the chemical reactions of this experiment.
So the first chemical reaction involved in this experiment is the combustion of sugar, where sugar is burnt and it forms a snake-like structure. And second is decomposition of baking soda.
Second reaction is the decomposition of baking soda, which is broken down into sodium bicarbonate and carbon dioxide.
And the third one is the formation of carbon snake, where, like he said, carbon dioxide is produced and it pushes the snake out to produce the carbon snake. And then I'll now be explaining to you the steps of how we conducted our experiment. So we get a non-flammable tray and we put sand in it, we fill it, level it, and we pour ethanol in it. So once the sand is soaked with ethanol, we add sugar and baking soda mixed in the ratio of 1 to 5. 1 spoon of baking soda and 5 spoons of sugar. So we mix them and add them on top of the sand and we ignite the experiment. Then we have to move on to stage 2. Stage 2 where the snake starts to form. And stage 3 is the final product of how our fire snake looks like. And if you look here, we have our fire snake happening here, where the sugar is burning to produce a snake-like structure here. Yeah. And like we said earlier, it's a slow reaction, so it will take time for the snake to fully form into that. And then, yeah.
Simply by changing the materials from paper to plastic, we changing the size from a small one to larger, or even changing the shape from a triangle to a circle, can really improve this.
Hello everybody. My name is Jalan.
My name is Akib.
My name is Hijau.
My name is Yogita.
My name is Maxim.
And we are the kinetic core. We have a demonstration of a Newton's cradle that explains the law of conservation of energy and Newton's third law. My teammate here will be explaining what is Newton's cradle.
The Newton's cradle is a device that shows us the law of conservation of energy and also Newton's third law. The law of conservation of energy is that energy cannot be created or destroyed, it can only be transformed or transferred. The Newton's third law tells us that every action always has an equal opposite reaction. Now my teammate Maxim will be explaining about how this model works.
So how does it work? When you lift one ball up, there is gravitational potential energy. And when it's dropped, this gravitational potential energy changes to kinetic energy, meaning the movement of energy goes through all these balls and reaches the opposite end ball, causing this opposite end ball to go up at the same angle as the first. However, Yogita, why do the balls stop?
This is because of two major things: air resistance and also energy dissipation. When we lift the ball up, there's air particles in front of it which push in the opposite direction of the ball. So when we release the ball, it gradually slows the ball down, meaning that it will eventually come to a stop. And if you realize, it also makes a sound. This sound is also energy. This means the energy is being dissipated or lost to the surrounding, so the model eventually stops. Now my teammate Hijau will be explaining how we made this.
Okay, now I'll be talking about what materials we used and how we made our Newton's cube. First, let me talk about the materials. We used a table frame, billiard balls, nylon string, and metal hooks. First, we used a billiard ball, and at the center, we drilled a hole. After that, we added a hook. We screw a hook inside that hole and added hot glue, so it wouldn't come out. Next, inside that hook, we kept a nylon string at the center and added super glue so it won't come out. After that, at our table frame, we added a nylon string and hung it using super glue so it won't come out uh, while doing our experiment. Now, my friend Maxim, no, now my friend Akib will talk about the real life example.
Some ways we can see examples of the Newton's cradle in real life could be dominoes falling. When we knock over one domino, the energy carries over, and when it hits subsequent dominoes, it causes them to fall over, causing a chain of reaction. This chain of reaction shows the transfer of energy. Another way we could see could be bumper cars. When a moving car hits a stationary car, the energy transfers over to the stationary car, causing it to move forward. I'll be continued by my groupmate Maxine.
So what is the conclusion? The conclusion is that when the ball is lifted and dropped, energy moves through these balls, causing the end ball to go up. This means that the input force and output force is the same, meaning it is equal. Now would you like to go see our other project?
Can you guys leave some space to do this? Um, what's that? Now, the reason Maxim have told you to come out is because we have another demonstration of the law of conservation of energy and Newton's third law. Maxim, show us how it works.
But Yogita, why doesn't the ball hit Maxine's face?
Like I said before, it's because of the conservation of energy. When we lift the ball up to a certain angle, it will not go beyond that angle because energy is conserved. Therefore, it will only go there because it cannot get energy out of nowhere or it cannot lose energy out of nowhere.
This is the end of our project, and Maxim will give us the outro.
Thank you for listening to us. We are the Kinetic Core.
Yeah, see, I tell you, echo. Yeah.
We recommend the camera to be behind the line. Behind the line. Yeah. Thank you. Hi everyone, we're the Atmospheric Avengers, and our experiment today is can crushed by air pressure. My name is Ivanka.
My name is Cassandra.
My name is Francis. My name is Dylan.
And my name is Matthew.
Our problem statement for today is, can a can be crushed by invisible force alone? Well, here's our hypothesis. If we heat a small amount of water in a can and then flip it into ice water, the can will be able to crush due to air pressure. Let's see if this is true. First, my teammate is going to be telling you the materials needed for this experiment.
The materials that we're going to use for this experiment is kettle, measuring cup, spoon, glove, tongs, stove, ice water, and cans. Fun fact is, we did our recycle module in 1 week ago, and we collected cans so we can reduce our cost for our project. Our aim is to collect 50 cans in a week, but we managed to collect 80 cans in a week. These cans that collected is fully contributed by the teachers and students of able learners.
Now, my teammate here is going to guide you through the step-by-step process for this experiment, while my other teammate demonstrates this experiment for you.
Okay, so the first step is that we pour 2 tablespoons of water into our measuring cup. After that, we pour the water into one of our cans. Now, using our tongs, we place the can on top of the stove. Now, we turn on the stove on high heat for around 30 to 40 seconds. After 30 to 40 seconds, we're going to quickly turn off the stove and we're going to dunk the can into the bowl of ice cold water.
Now you guys are probably wondering, how can a can be crushed through air pressure alone? Now, we must understand how can air pressure make a difference on the can. When we boil the water inside of the can, in the process of evaporation, steam fills up the can almost instantly. This pushes the air outside of the can. Now, when we flip the can into the ice cold water, almost rapidly the steam inside of the can cools up. And because of the less of air pressure inside, the cooling effect causes almost no air pressure inside of the can at all. However, outside of the can, there's a high chance of air pressure. And because of this air pressure, this causes the can to implode on itself.
What is actually going on inside the can in terms of particles? When we heat up the can in the liquid state, it then turns into gas molecules. Gas molecules gain energy and come closer together. Since these gas molecules have a lot of energy, they bounce around in the can and pushes the remaining air out. Then, once we flip it into the ice water, the gas molecules then condense back into liquid molecules. These liquid molecules come back into the liquid state, which is now the particles are weaker and further apart. Now with fewer particles in the can, the outside air pressure pushes air inside the can, causing the can to crush in iced water.
This experiment might look fun, right? My teammate Dylan is going to explain how this concept can be used in real life.
Now, this may look like a fun experiment, but this can also be applied to real-life scenarios. For example,
airplanes. So, for example, when a plane is running down the runway, it obviously needs a significant amount of energy. So, air pressure actually helps with this. It helps move the flaps to propel the plane into the air. And while the plane is in the air, the flaps actually balance the plane in the air due to air pressure. And also, weather systems also depend on the understanding of air pressure. But we can also use the understanding of air pressure even at home. For example, when we're drinking from a straw, we are also using air pressure by reducing the pressure inside the drink. So air pressure helps the drink from the cup flow into our mouth.
Now, going back to my problem statement, I asked, can a can be crushed by invisible force alone? Well, as you can see, it can. My hypothesis mentioned that if we heat up a small amount of water in a can and then flip it in the ice water, the can will be able to crush due to air pressure. In conclusion, my hypothesis is true. This experiment shows that air pressure exists and it's all around us. When steam pushes the air outside of the can and it cools down, it becomes low pressure. The difference between the high and low pressure causes the can to crush. What is the importance of this experiment? It shows us how invisible force exists all around us. Even though we can't physically see it, the power of force is still very strong and it's all around us. And that's all from us today. Thank you.
Safe to perform this experiment at home?
Yes, with safety precautions like wearing gloves.
So the viewers, like, especially the kids, are doing it. Can you like just advise them to don't try at home?
Do not try this at home without supervision and without safety equipment. And if someone is watching another person do this experiment, make sure you maintain a distance so the water doesn't splash on you. Backlight.
Thank you.
Good morning, guys. We are the Electric Forces, and we're here today to present about the wonderful topic about electromagnets.
So what are electromagnets? Electromagnets are temporary magnets which produce a strong magnetic field using electricity. Best thing about it is that it can turn on and turn off.
Where are they used? Why can't we just use permanent magnets?
Great question, Thomas. Electromagnets are used in scrapyards, where the electromagnet produces a strong magnetic field to attract cars and oft to drop them off to a compressor. They're also used in MRI scanners, where strong electromagnets scan and image the inside of your body. Maglev trains also have electromagnets, where the train and the track both contain electromagnets. They repel and continuously switch poles using a linear induction motor and propel forward. Magnetic door locks also have electromagnets. They only unlock when electricity is turned on. Yes.
Adding on to her information, if permanent magnets are used instead of electromagnets, scrapyards wouldn't be able to drop and release metallic scrap, MRI scanners wouldn't be able to function properly, and wouldn't be able to control the waves, maglev trains wouldn't be efficient and they wouldn't be able to work, and magnetic door locks wouldn't be secure, and they would cause major problems like theft.
How are electromagnets better than permanent magnets?
Electromagnets are much better than permanent magnets because they're controllable. Their polarity can be reversed by changing the direction of the current, and lastly, the strength of the electromagnet can be changed by the amount of current you use. Other than that, permanent magnets are unable to do any of these. Now, to make a simple electromagnet, you only need 4 essential materials. This consists of your iron nail, your copper wire, your main source of battery, which is your main source of energy, which is your battery, and lastly, your paper clips, as you need this to test the strength of your electromagnet.
Now, before we find out how to make an electromagnet, do you think a normal iron nail can attract paper clips? No, that's right. Do you think a copper wire can attract paper clips?
No.
That's right. Okay.
As you can see,
Okay.
cardboard has
So,
been the
but did you know that the iron nail coiled with copper connected to a battery
Thank you
source
so much for listening.
can attract paper clips? Slow, slow, slow. Yeah. Okay. Can I get a volunteer to test out 100 coiled electromagnets? Okay.
So you need to connect these sides to the positive and the negative sides of the battery. Then hold it. Then stick it to the pile of paper clips.
Move it around. Move it around. Yes. Okay. And now lift it up slowly. Yes. Just drop it here. Yes. Thank you. Thank you. 200. That's much. Thank you. Can I have another volunteer to test out 200 copper coils? You need to connect the ends of the battery to the coil to the positive and negative side. Move it around, move it around, and lift it up slowly, slowly. Yes, yes. Okay. This shows that the more amount of coils around the iron core, the stronger the electromagnet.
So don't forget our side experiments, which is the maglev train. Maglev train works
by when it levitates with the help of electromagnets. So you can feel someone in demo. So you can feel the repulsion with the train and between the train and the train track, like poles.
So, like poles repel, maglev train repeatedly change poles from north to south, which repel and attract, causing the train to propel forward without the usage of wheels.
So now we're going to be showing you a real life example of maglev trains. This is a battery and magnets which are connected to both positive and negative sides. The battery contains power inside. It produces a magnetic field producing electricity. So you push in the battery.
Try both positive and negative side.
Wait, you said that only. Same one.
I got it. Okay.
Sadly, our moving model of the maglev train doesn't work currently. So what is supposed to happen is this is supposed to flow through this copper wire and come out and descend due to these magnets. Thank you for listening to our presentation.
Put the price. Can you separate a bit? Can you see the like what? Sunny, you can Sunny. Yeah, put it behind you. Come closer. Ah. Okay. Present exactly like your present just yeah, okay? From your names, huh? Yes. Names also. Okay, fine. Okay, I'll tell all of them, then I'll tell after. Okay. What do I call you as? Ma'am or sir? What do I call you? Ma'am, sir. You can call sister. Okay. Arjun.
Just say hello.
Viewer. Hello, viewer.
Audience.
Okay. Hello, audience. Good afternoon. In your opinion, how does friction affect the motion of objects sliding down the lamp? Yes, no, I don't know. It's okay. We'll find out by this experiment called friction lamps. First of all, let me formally introduce ourselves. Our group name is Of the Lamp. My name is Akshara.
My name is Nandita.
My name is Afra.
My name is Kaila.
Now, I'm going to tell you first of all what is friction.
Friction is a force that opposes motion between two surfaces in contact. It plays a crucial role in our daily life, from walking on the ground to driving cars. Without friction, we would simply slide around uncontrollably.
Now since we know what's friction, let's talk about what's friction ramp. This is a friction ramp. This is a friction ramp. A friction ramp is a tool that demonstrates the principles of friction and motion using an inclined plane, also known as a ramp. It uses smooth and rough surfaces to demonstrate how friction affects the motion of different objects sliding down a ramp.
We'll be using 6 different materials that consist of smooth and rough surfaces to demonstrate how friction works. Here we have it is aluminium foil.
Now we're going to slide aluminum foil down the ramp.
Now we're going to record the results. Now we're going to use foam. Foam travel not that far. Now we're going to use cardboard. Cardboard travels pretty far, as you can see. Now we're going to use sponge. As you can see, sponge didn't travel at all. Mark it. Now we have the star of the show, ice. Wow, ice traveled the furthest, as you can see. Now we're going to explain why some materials had traveled the furthest, some the least, and some didn't travel. Why did some materials travel the furthest?
From our experiment, if you have observed, you might have noticed that objects with smooth surfaces like ice, cardboard, aluminium foil have smooth surfaces, which means that they have fewer bumps, which creates less friction and allows them to slide more easily and travel a further distance.
Why did some materials travel the least?
Rough surfaces like foam have more bumps, which creates friction by grabbing onto the surface.
How about sponge? It didn't travel at all.
Materials like sponge naturally have better grip than others, so it does not travel off the ramp.
Now, I'm going to show you an application of friction. As you can see over here, there are two shoe soles here. Which shoe would you typically wear while going out? Well, I would prefer this shoe because it has more friction, which allows us to push forward and walk properly and have better grip. Whereas this shoe, it has a smooth surface. So this creates less friction, so it slide and makes it difficult to walk. Now, I'm going to tell you another application of friction.
Another application of friction is a game of tug of war. You might be wondering, tug of war and friction, how is it related? Our teammates will demonstrate it. This is a glove with more friction. This is a glove with less friction. Can you please pick one?
A volunteer goes here. Okay.
Before we start, what do you predict? Who do you predict will win this game? A glove with less friction or a glove with more friction? Let's find out.
1, 2, 3, go. You guys are not even losing already.
Oh. So, based on this game, a glove with more friction provides a better grip and prevents the rope from slipping, whereas a glove with less friction makes your hand slide, so you lose strength and grip.
Now, I'm going to tell you an interesting fact about friction. An interesting fact about friction is that the laws of sliding friction dates back to 1493. That was so many centuries ago. But who discovered it? First, it was discovered by Leonardo da Vinci. He documented in his notebooks. But it was not published. Then, Antonio, a person who had discovered this law and made it into his own. These days, we call it the third law of dry friction. Now, we have a little game for you. It's called the game of luck. There are some materials in it, including a mystery material. Let's do also. Me first? Okay.
You both do it. Shake it. Okay. Pick one. What do you got? Eyes. You got eyes. And you got
Cardboard.
cardboard. Let's see who's the winner is. Ice versus cardboard. First, let's test out cardboard. Let's record the results. Ice. Now we have ice. Wow! Ice has the furthest as you can see. So ice has won the race. Thank you so much for listening.
Thank you. Thank you.
Thank you. Thank you. Yeah, sure.
So you can go to at 1 o'clock.
Right at the center. So we calculate the string length, and instead of just using, for example, if the string is 70 centimeters, we originally calculated this whole thing as 70 centimeters. Instead of that, we calculate from here right until the middle of the ball, and it doesn't weigh as much because it's at the center of mass. So we wanted to show you a video that demonstrates the concept of angular weight and center of mass in the film industry.
I'll just show you guys the video.
So in the video there will be trains and people on top. So the trains act as a pendulum and they vibrate, move, they oscillate and fall at different frequencies. And the people on top, they'll position themselves in a way so that the center mass is lower so that they'll be able to stay on top of the train without people falling. Okay.
Now as you can see, the train is moving and we are also moving. Yeah. So this is a music video that we made which had a very accurate sound.
Yes. All right. Thank you. Very good. Well
Thank you
done.
so
Well
much.
done.
So you can go there, get the experience of
Yes.
presentation and some
Okay. After giving this certificate. Oh, thank you.
Present exactly like your present to the judges. Oh, from your name, sir.
All everyone talk.
Let me show you an example. If I did it right,
Hi, good morning. Welcome to Pendulum Nights. My name is Shaumya and these are my team members Sharon, Marcus, Shreen and Jamuna. So,
what we are talking about is pendulum wave. So what is a pendulum wave? A pendulum wave is a demonstration that shows how each pendulum swings at slightly different lengths due to having different frequencies and string lengths. You see, I'm going to show a my friend is going to show a demonstration, and you see, at first, the shape moves like a snake in an S in sync. Now it's drifting apart and out of sync. This is due to different string lengths. A complete cycle occurs after 30 to 34 seconds. Now, the longest string at the back will always have a slow swing, but the shortest string at the front will always have a faster swing. Now I'm going to pass it on to Sharon, who's going to explain the apparatus and the experimental procedure.
Hello, I'm Sharon. So the apparatus we use for the experiment are nylon strings, silver nuts, and it's covered with clay, a frame, and a cardboard. So I'll take you to the procedure now. So we cut 8 strings of increasing length. We tied each to a silver nut covered with clay, and we attached them to a frame, and the spacing between each pendulum is even. After that, we used the cardboard to take all the pendulums to one side, and we release them simultaneously. This creates a simple harmonic motion, and that's how you're observing these different patterns. Now, I would also like to tell you about how we obtain each length for each pendulum. As you can see, the formula T equals to 2 pi square root L over G. Using that formula, we got to know about the oscillation of each pendulum, and based on that, we also got to know about the length, and that's how each pendulum is placed here. Now I would like to pass it on to Shreen and Jamuna.
Some of the real-life applications for pendulum waves are used in education, music, earth science, and engineering. And I'm going to explain in more depth. So basically in music, I'm sure all of y'all must have favorite songs and music that you like to listen to. So how do people follow the rhythm and the beat? In the Western world, there is a device, an instrument known as a metronome. The metronome is one singular pendulum that you can control the beat and the rhythm of. So when musicians and artists play songs or dance, they don't go too fast or too slow. Next, you have engineering. So you must wonder, we've seen so many tall buildings and tall towers. How do they not topple over due to strong winds and earthquakes? So there are large pendulums inside. Talking about in Malaysia, we have the Twin Towers. The Twin Towers have 3 tuned mass dampers in each tower. That means 3 here and 3 here. So basically they are like pendulums, but they are large and they prevent the towers from falling over. So let's say when the strong wind hits the tower, the building sways and moves, but it doesn't topple over. Thank you. Now I would like to pass it back to Shaumya. So, you may think that this setup is easy to make, but that was the complete opposite for us because we faced many hiccups along the way to set up our startup pendulum. Well, now I'll pass it on to Mr. Marcus, who's going to explain the problems that we faced and how we overcame those challenges.
So at first, we didn't have just 8 pendulums with clay. We tried to do it with 32 of these nuts, but the problem we faced was each gap had 1.1 centimeters, so it's very tight. And because of the gap inside these nuts, if air passes through, it doesn't only sway left to right, but back and forth, and it also rotates. So if one gust of wind comes through, it'll hit one of the pendulums and all of them will collide with each other, so this wave pattern won't be formed. So to fix that, we used clay, and we covered the holes and wrapped it into a ball. Because it's a ball and it's a regular shape now, it has a center of mass at the geometric center. So when we calculated the lengths, originally for the nuts, we calculated from the very top till here. But after we made it into a ball, we, instead of just calculating from the top of the frame till the very top of the nut, we calculated at the center, so it'll be more balanced and it won't just spin around and go back and forth. It'll follow the wave pattern. Now, for each pendulum, we use the formula T equals 2 pi square root L over G. Now, each pendulum has to have a specific oscillation. For example, if this pendulum has oscillation of 59, That means it moves back 59 times, sways back left and right 59 times in the span of, for this pendulum, specific pendulum, it's the span of 30 seconds for our period. So if this has 59, the next one must have 60. So we have to use the formula for each single one to calculate it. Now, I want to show a video that demonstrates the concept of pendulum. No video. First, we want to move it on to the center of mass, and then we'll show the video so that you can understand both concepts.
Hi, my name is Dalina Isha, and I'll be giving you the introduction to our group, Center of Mass. Okay, so basically, what is center of mass? Center of mass is something that we use in our daily lives, but not really noticed well. Okay, what is center of mass scientifically? Center of mass is something when an object is exactly, the mass of an object is evenly distributed, that the balance of the object is perfect in all directions. Now, why does center of mass matters? Center of mass is essential for running, jumping, dancing, and even transport systems like cars, bicycles, metros, and even spacecraft. That's why we 0 Point want to also incorporate with spacecraft and space team to explain to you what is center of mass. Now, let's skip all this theory part and go to real life application. For our real life application, have you ever noticed when you carry a heavy bag, especially on one side of your shoulder, you will tend to lean and balance yourself? Yeah, that is when your center of mass will find to balance yourself. Now, there is an interesting fact actually, incorporating with animals, center of mass especially. How do llamas stay steady while pooping? Now, llamas usually widens their leg to increase the surface area. They go below and lower to make the center of mass stable so that they can poop steadily. Alright, now I'll be passing on to Litika, my friend, to explain more in depth about space, center of mass.
Hello. For irregular objects, the center of mass is not at its geometrical center point. It's usually evenly spread out. So, for example, this screwdriver over here has a center of mass at its handle because it's the heaviest over there. So if I balance it on this end, it will balance because the mass over here is heavy, but the length is shorter. The mass makes up for the higher length, and the length over here on this side makes up for the lesser mass. So for space, we have meteors, and for example, this meteor, irregular objects such as this will have a center of mass not at its center, not at its geometric center, but spread out evenly. It has the center of mass at its heaviest point and will enter the Earth's atmosphere at its heaviest point. I'll pass it on to Keshan to explain more about regular objects.
Thank you, Litika. Now I'll be explaining about regular objects, which is much more simple than irregular objects. I have my friend Uzaid here to hold the board for me to do the demonstration. For regular objects, the center of mass is usually at the geometric center, which is the exact center. So Uzaid, can you put your hand at the geometric center for me? As you can see, he's holding it by one hand, it's balanced. Because from this center here to this point, it is exactly the same here. Both have the same length, same mass, and the gravity that is acting on both parts is the same. Because of that, it is staying the same. Same thing for this bird. Some people wonder, how does it stay balanced like this? Because if I hold it like this, it's drooping down. If I hold it like this, it's also drooping down. But if I hold like this, it's staying steady. It's because at the end of both wings, there is mass there. If I draw a line from this part to the end here, and find the geometric center, it is at the beak. So if I balance it at the geometric center, it is perfectly balancing. That is how it's supposed to be. Now I'd like to pass the mic to my friend Uzaid to demonstrate the plumb up method to find the center of mass for irregular objects.
So, you won't actually know where the center of mass is in the irregular object because it's all mixed up. What we do is a plumb bob experiment. We have a plumb line and irregular shape. From any edge of the shape, you can make any points. I have made these 2 points. So you put the shape inside the plumb box experiment and hang this plumb line on top of it. As you can see, it straight goes down, right? It's freely. As you can see that the plumb line is going down. This shows that the center of mass is from top to bottom on this line, nowhere else. I'm going to draw a line here. Now, it shows that the center of mass is somewhere on this line. But to find actually where it is, you do the same thing with another point, hang the plumb line on top of it again. You can see this line I drew earlier and this line is intersecting at one point. Here. You can see that it intersects at this point. This is the center of mass of a irregular shape. To actually find out if it actually is, you can balance it on your finger. Now if I balance it on my finger, you can see it's a balanced, right? It's not dropping. I'm pointing at the point I drew here. So this is the center of mass. Yes? Yes.
That's balancing. It's away a bit from the center. Yeah. Just so.
Yeah. Thank you.
Okay, now I will be using my friend Uzai to use his body test challenge. I will be using the wall there. Uzai, can you follow me? Kishan? Okay, this challenge is a body test challenge. This is something that is hands-on experience for our volunteers who come here, and also they will get to know how does their body work with the center of mass. Uzai, are you ready to try?
Yeah, sure.
Yeah. The first challenge is wall sit challenge. Now, Uzai, you're going to follow what I'm going to say. Sit 90 degrees, bend your leg 90 degrees. Go more down. Okay, now try to lift your right leg up. You cannot, right? That's because your center of mass is evenly distributed to your 2 legs. And if you try to lift one, you will have difficulties to lift one up.
Mass shifts to the other side. So there's no mass here. So this is where your leg drops down.
Okay, now we're going to go for the second challenge. The second challenge is chair lift challenge. Alright, Uzai, from where you are, take 2 steps back. 1 and 2. Now, Uzai, you're going to move in front, lean, and make sure your head is touching the wall. Okay, now I'm going to push this chair in. Try to lift this chair to your chest and come up. He cannot, because when you lean too forward, especially to the wall, your center of mass will move towards the head and your head will have more pressure and heavier. This is where you will have difficulties to lean up back. Alright, the last challenge is tightrope walking. The tightrope walking is here. Now I will be using Litika, my friend here, to try the tightrope walking. Okay, Litika. Now what you're going to be doing is, you're going to be walking on this with your hands on the side and try to balance and come to the end. Okay, difficult?
Is it difficult? It's very difficult.
Okay, now go back and put your hands straight and walk. Do you find it easy?
It's much more easier.
This is because your center of mass is evenly distributed to your hands, which is more easier for you to walk and more balanced. Thank you so much.